In this video, we will be developing the double angle identities. To do this, we will use the sum identities. So to start with, we're going to develop the sine of 2a. So we'll use sine of a plus b is equal to sine of a cosine of b plus cosine of a sine of b. Now the only thing this changes is that if we want the sine of 2a, that's the same as the sine of a plus a. So basically it's the same thing, but instead of putting a b here and here, we'll have another a. So this is the sine of a times the cosine of a plus the cosine of a times the sine of a. All we did was take the b out and put in another a because we're doing a plus a. Well, if we use the commutative property, this second term is the same as sine a cosine a. So this is sine a cosine a plus, and then commutative property says I can turn these around, and this is also sine a cosine a. So if I have one sine a cosine a here, and one sine a cosine a here, and I'm adding those together, then my sine of 2a, which is what I want, will be 2 sine a cosine a. So this is my double angle identity for sine. Now let's do cosine of 2a. To find the cosine of 2a, I'm going to use cosine of a plus b is equal to cosine a cosine b minus sine a sine b. So for cosine of 2a, I'm going to write cosine a plus a. And again, I'll just take the b out here and here and put an a in its place. So cosine a plus a is cosine a minus sine a sine a. Now whenever we have two factors multiplied together and those factors are identical, we can write that as the factor squared. So I can write this then as the cosine of 2a is equal to the cosine squared of a, subtract, and then here again I have sine a, so that can be written as sine squared a. So this is one of the double angle identities for cosine. Now we can get two more using sine squared a plus cosine squared a is equal to 1. We can subtract cosine squared a from both sides and get sine squared a equals 1 minus cosine squared a. Now I'm going to substitute this expression in up here and get another expression or another identity for cosine 2a. So I have cosine 2a is equal to cosine squared A, subtract, and then in place of sine squared, I'm going to put in 1 minus cosine squared. And distribute my minus. This will be minus 1 and a plus cosine squared A. So putting these two together, I get my next identity, cosine 2A, is equal to 2 cosine squared A minus 1. So this is another one. And then to get one more, come over here. I'm going to use sine squared plus cosine squared equal 1 again. And this time I'm going to replace the cosine squared. So from my Pythagorean, I know that cosine squared A is equal to 1 minus sine squared. And so then let's go ahead and take this identity and plug in that expression for cosine squared. So I have cosine 2A is equal to 1 minus sine squared that's here, and then minus sine squared. So now I can combine these two terms and get my third sum identity for cosine. It is 1 minus 2 sine squared A. So here's one, and here's another one, and here's our third one. And finally, let's develop our double angle for tangent. We're going to use tangent of A plus B is equal to the fraction tangent A plus tangent B over 1 minus the product tangent A times tangent B. So now if I have tangent A plus A, I get tangent A plus tangent A over 1 minus tangent A times tangent A. So we can simplify the top. Tangent A plus tangent A is 2 tangent A. So my identity then for tangent 2A is 2 tangent A over 1 minus, and then tangent A times tangent A, we can write that as tangent squared. So minus tangent squared A. And this is my double angle identity for tangent.